All right, T7C antenna measurements and troubleshooting, measuring SWR, dummy loads, and feed line failure modes. What is the primary purpose of a dummy load? A dummy load is a device that you hook up to your transmitter instead of an antenna when you're testing. Okay, so it does not transmit a signal over the air. So the purpose of the dummy load is to prevent the radiation of signals when making tests. Okay, and it's called a dummy load because it loads the transmitter in the same way that an antenna would, but it doesn't transmit, or doesn't transmit very much at least. Okay, which of the following instruments can be used to determine if an antenna is resonant and at the desired operating frequency? That instrument is an antenna analyzer, and the antenna analyzer is very, very useful instrument. When you're putting up antennas and so on. If you don't get one for yourself, find out if your local club has one that you can borrow. What, in general terms, is standing wave ratio? Okay, standing wave ratio, we usually call it SWR. It's a measure of how well the load is matched to a transmission line. And it's important that these loads be matched to get the maximum power transmitted through the system and to your antenna and out as a signal. This is a nifty little graphic that I found. I've never seen anything better for showing reflected power. And here we have a signal going forward, okay, and it gets to a discontinuity in the system. Here we have 50 ohm coaxial cable connected to a 200 ohm antenna. Okay, and when that signal gets to there, part of it is reflected back. Signal gets to that discontinuity, part of that's reflected back. Let me give you another example of the same thing. If you're standing in a doorway, open door, showing a flashlight out into the yard, all of your flashlight beam goes out in the yard to illuminate what you want to see, right? Okay. What if you do that at a window? If you're standing at a window, shining your flashlight outside, what do you see in the window?
Flashlight.
You see the flashlight, don't you? And that's exactly the same thing that's happening here. You have a discontinuity because of the glass. The speed of light is different through glass than it is through air. And that causes reflected power from your flashlight to come back to your eye. So the same thing happens in a transmission line with radio frequency energy. And I could think I could sit and watch that all night, but we won't. It's such a good illustration. I have tried in times past to demonstrate this in some way, to show it on a chalkboard, and nothing does it like this one. Okay, what reading on an SWR meter indicates a perfect impedance match between the antenna and the feed line? If we have a perfect match, that's called a 1-to-1 standing wave ratio, and that indicates a perfect impedance match. If we went back to the other slide, you'll remember we had a 50 ohm transmission line, we had a 200 ohm antenna, and that would be a mismatch. That would be a 4-to-1, in fact, mismatch. If we were hooked up to a 50 ohm antenna, then we'd be 1-to-1, 50 ohm feed line, 50 ohm antenna, 1-to-1, and it would be a perfect match. What's the approximate SWR value above which protection circuits in most solid-state transmitters begin to reduce power? Once the transmitter sees an SWR of 2-to-1, it will start shutting down to protect itself from being damaged. Okay, so above 2-to-1, and some of them before that, but at 2-to-1, most of them will be starting to shut down to protect themselves from damage. What does an SWR reading of 4-to-1 mean? It means there's an impedance mismatch. Impedance mismatch. What happens to the power lost in a feed line? Like almost all power lost in all systems, it's converted into heat. The lost power is converted into heat. What instrument other than an SWR meter could you use to determine if a feed line and antenna are properly matched? An instrument called a directional watt meter will let you see that. A directional watt meter will let you look at the power forward and then you can switch it to see the power back. So it separates the two directions of the power going through it. So if we were looking at that graphic, that animation that we had with a directional watt meter, we would see a certain amount of power going forward when we had it set for forward. If we turned it to reverse, we would see the power that's being reflected. Which of the following is the most common cause of failure for coaxial cables? Moisture contamination is the most common reason for failure. It causes corrosion, and the moisture in the water in the system will also absorb energy, just like if you put a cup of water in the microwave, it gets hot. And the same thing can happen. Same thing can happen in the microwave cable. Excuse me for a second here while I get a little water. Why should the outer jacket of coaxial cable be resistant to ultraviolet light? And of course we know that sunlight has a lot of ultraviolet light in it. Ultraviolet light can damage the jacket and allow water to enter the cable. So if the jacket of the cable is not resistant to ultraviolet light, the sunlight can cause damage to the cable. What's the disadvantage of air core coaxial cables when compared to foam or solid dielectric types? The air core types require special techniques to prevent water absorption into the cable.